We did discuss about creating a proxy and how the dynamic proxies gets created and in which phase it is created, right? So that's everybody is clear about it. Okay. So now we'll see uh, the aspect-oriented programming. First, we'll understand what is the aspect-oriented programming. Then we'll talk about how, and what Spring supports. So what is this AOP is trying to solve the problem? Anybody who are already worked on AOP or having a knowledge about AOP can.
So basically, we call them as cross-cutting concerns, right? So elements which are not part of your core business logic, but still you need them for other non-functional reasons. The non-functional reasons could be, logging in, logging, uh, transactional, so which might not be actually part of the business logic. At the same time, you don't want to spoil your code by putting in all those boilerplate stuff in between the codes. So you want a mechanism where you control it as a configuration or an annotation so that it's part of the code but still, outside your business logic. So the code is clean.
Good. I think you covered all of my session today. Okay. So I think you covered very nicely. Thank you. As you said, AOP is like aspect-oriented programming, enables modernization of cross-cutting concern. Okay. Uh, to benefit for others, let's go a little more deeper to understand what is this modernization. Let's understand what is a modernization. What do you mean by modernization here? It says AOP programming enables modernization. What do you mean by modernization?
Manju,
Mapping it to.
modularization means. Go ahead, sorry.
Hey, sorry, you go ahead, Amit.
Okay, I think modularization is all about grouping the same task that can be done by any software entity.
Okay. Any other definition or any other understanding? It's a valid.
Yeah, on the same lines. Yeah, on the same lines of Amit. So modularization in terms of so what we want to achieve. So logging is one module, transaction is another module.
Okay. All right. So I think one specific, if you take any Pojo, okay, if one function does one thing very well and focused, and if that function or method is reusable in many places, and this is called as a modularization. It could be anything. It could be security. It could be transaction or anything. Okay. So modulation. If you take a look at the C programming, right? The function which you define and put that function in a library and add it in an include file, header file, then somebody can go and use it using the header file and library. You can access that method, a function, right? That function gets reused in many places so that the code what it has been is part of a library. Okay, this is the kind of things you do it in a C, and in a Java you go and write an interface and implement it and provide an implementation for that, and other people can use it many places if they want to consume the similar functionality. That's the modularization. And now with having all this modularization which is provided by Java object-oriented programming, there are still some portion of the code we are unable to do a modularization. For example, okay, if you look at the code where I wanted to introduce a logging or transactional behaviors, you have a business logic, and if I want to introduce a transaction behavior, I will have to go and put the transactional behavior code interleaved with your business logic. So the transaction plus business logic gets combined together. And Even though I go and write a separate method to open a transaction, but the open transaction method has to be called inside your business logic, business function. So this portion of this segment of the code is still unable to modify with having still a OO concept. Okay, so those kind of codes, which is called as, which will go and cut across many functional blocks, or as a called as a cross-cutting concern. Like if you have the cross-cutting concerns, like logging, if I want to go and add a log for entering a function and exiting function, like an instrumentation codes, if I want to add it, I will go and insert this logging code every starting method at the end of the method. Okay, but this logging is a separate thing out of your business logic. This logging entries will be there intercepted in your existing functions or method. Similarly, transaction. So like this, you will have a lot of this kind of functions which will kind of concerns get cut across the business logic. The functional blocks is like your actual business logic. Okay, whether you wanted to commit a customer or orders or line items or committing to the accounts, anything if you take, all of these are functional blocks. Customer updates, order updates, account updates, dispatching update, all of these are the functional blocks. And each and every functional blocks, you have a generic cross-cutting concern, which is transactional behavior is same across all the business functional logic, whether it you take customer or account or order or any dispatcher logic, this transactional behavior is the same across every functional block. This kind of generic logic cut across different functional blocks. That is called as a cross-cutting concerns. Okay, and if you take an example, this is a generic functionality that needs to be in place in many of your applications like logging, transaction, security code, caching code, error handling, all performance monitoring like instrumentation code, things like that. So these are all called as a cross-cutting concern. Okay, all these cross-cutting concerns which will cut across many functional blocks. So in these situations, we are still unable to do a modularization with having a OO concept. Okay, so for example, if you have a requirement, perform a role-based security check before every function, every application method. That the moment you say every application method, in all service method, you need to go and put a security check. So this is like something which is a requirement, is a cross-cutting concern. What you do is you go and put a logic to check the security check in each and every service level methods. Okay, so that security code is a generic across all the functional block, it will cut across. That's a cross-cutting concern. So now if you don't modularize these cross-cuttings with a business logic, you will lead to two kinds of problem. One is code tangling and code scattering. Code scattering is same concern is spread across different modules. So code tangling is the business logic and other cross-cutting concern logic is there coupled together. So it's a separation of concern. Now if you look at the tangling, this is how your code looks like. If I have like has a permission, okay, this is the security check and this is my business logic. Okay, and moreover, in your if you take your code or any existing code where the different kind of cross-cutting concern cut across the many functional block, okay, you need to go and do a security check and you need to open the transaction. You also need to do a logging. If you read like 3-4 different cross-cutting concerns get cut across the your business logic. If I have such kind of code like security, transaction, and logging, and plus my business logic, what kind of problem I'm going to hit with having this kind of code? what's the problem with having this kind of code?
It's very difficult to decouple
Mm-hmm.
as one. And so, I mean, when we are talking about NFR, it's basically the manageability issue. After some time, it becomes, I mean, too much tightly coupled an application where, you know, if I decide to say, for example, if I decide to go with a different security vendor, now it is almost like a rewrite of entire application, touch every method, change the security functionality. So
Let's
it's
say,
basically the decoupling part.
got it. Let's say if I'm using this security in only one place with like this. If this kind of code is there in only one place, is it a still problem or it's okay?
Uh, Himanshu, I mean, if we look at this code from a business perspective, then that checking of security is should not be part of business logic. So it can be or it should be taken away from this method.
Correct. So we all know that it should not be there. If it is there, what is the kind of problem I'm going to hit here? See, if I go and say this code is bad, I should go and pinpoint because of this it is bad. What is that bad with this code?
Uh,
What I'm going to hit out of it?
I mean, I think the bad is, once after you are entering the method, you are throwing the exception by checking the permission. So I think we can do this before entering the method.
Yeah, exactly.
No, I mean, it's very difficult for us to, if I have to disable the security, it becomes a problem. I mean, I'll not be able to control it outside this method. I mean, security is something which has to be controlled outside the method, right? So it's very difficult in this case to control security outside the scope of this method. So if I have to add more stuff into the security, then what I have to do is I have to come and change the code here in some cases, or
Okay.
comment out the code or whatever.
Okay. Let's say case I don't need to go and change the code or comment.
Mhm.
What's the problem?
Manjunath,
But
Bilish here.
Yeah.
If this
sorry,
is one or two method, then this code is okay. But if we need to have the same security across different methods, a lot of method in our application, then it's a code duplication everywhere.
Correct. That's a different problem. Okay. If the same piece of the code is there in multiple places, that's a different problem. Okay. Let's say the same piece of the code it exists in only one place, and I have a security, I have a transaction, I have a login, and in between I may use some local, Boolean variable to set true or false, things like that. And finally, based on the true or false, I'm going to make some decision here. Let's say I have that kind of code. What's the problem with that code?
If I need to make some changes, actually, I need to make change in so many places in future.
Yes, let's say that kind of piece of the code is there in only one place. Is it a still problem or not?
I mean, say one place in one method, I think that's okay actually.
Okay. So as I said that if I have the code like has permission, like, and I'll put the begin transaction, and in between I use some local variables. I'll say if this is set, then only I'll make the that local variable true or false. And next method I'll go and check if it is that is there. I will make set true or false, or something like that. And finally, based on true or false, I'm going to execute my business logic. If I have such kind of logic, if you look at, okay, and somebody is going to introduce that previously it was not, let's say that was not there, Boolean expression, okay, somebody is trying to fix the issue, and they introduce the Boolean because they want to make sure that the flow which is goes in only after this, and they want to remove some of the exception like that. Okay, based on the true or false, they want to go and execute. uh, they test only their part of the code, because there will be a security team, there is their database team, and there's a business logic guys who is going to implement the business logic. So somebody raised the issue that this is a permission is not happening without been checking. Somebody is going to introduce that kind of Boolean attribute, check it. If this is the case, then go and execute, otherwise don't execute. And they won't test completely on the business logic or other logic. They just go and test the security part and checks in. Okay, so that actually has a break or a bug in this code. So the actual QA team is going to raise a bug. This is actually causing an issue. When they come and fix this issue, somebody sees that like there is a Boolean attribute, so they remove the condition or alter the condition. Again, they test it only this part. They don't test the security part. Okay. If you look at the kind of code, what it is there in the this kind of logic, with having those kind of local variable where you turn on, turn off a Boolean value, it becomes extremely difficult to maintain the code. Because when you fix this, the other problem is going to open. When you fix this problem is going to open. And both the team will be different. And sometimes the old problem which is fixed will be reopened because you have screwed up. Somebody is going to fix this, has been screwed up the other part. And once they close it, they won't test it again. Maybe customer is going to test it. Many cases. Okay. So maintaining this kind of code is becoming a very, very big problem in many of the applications. Okay, you would have seen in many of the existing project, there are some critical block of the code. We are very scared to touch that part because if you touch it, it's going to cause a regression issue, right? So those pieces of the code, it's a very, very extreme to very high maintenance issue. So that is one problem. Okay. Another problem is where we have a code is being there, every places. Okay, the same piece of the code is there in all the places. This is another problem. Okay. Now, let's say when you started developing this different services like bank service, customer service, reporting service, you are taking care of designing very well. Okay, all the function being implemented with very well, and it has been testable and all those stuff. And the moment there is a requirement for a security team comes up with a requirement, the security team will come and add your the security check code in each and every functional block. Okay, and again, like when there is a requirement for the transaction to add, transaction team or database team will come and add this code in between your existing function block. And somebody asked that I wanted to figure out all the instrumentation code, how much time is going to take for each and every method, critical method. So there is a logging request. So they go and do a logging. So logging code will be added in your functional block. After a couple of months or weeks, if you come back and see your existing code, there is a lot of other piece of the code got inserted. Okay, so now it is the code is scattered across, and within the same function you have a tangle. Okay, so this becomes difficult to manage the existing code. Okay, so what AOP is trying to address is, okay, it enables the modernization of cross-cutting concerns. So it is trying to avoid this tangling and eliminates the scattering across. So that is where the AOP come into picture. How does this AOP works? Very simple. And keep your existing functionality as it is. When there is a new requirement is coming where that kind of generic logic cut across different functional block, what you do is you just go and write a separate class and a method. In that method, you go and put the logic. Okay. Now I want to go and insert this logic in the place where I need to go and select certain methods and insert it. Okay. For that, I'll go and write an expression and bind that to a method. Okay. And the whole binding of this expression, which is going to select this method or insert wherever it is required, the logic which is written in the method, that's a functional block, and give it to a framework, okay, where this aspect, which is a generic logic to be inserted in many places, and it goes and takes this generic logic and weaves into an appropriate place. That appropriate place has been selected by your expression, which is attached to that method. Okay, so whole thing, the now physically, if you look at the generic cross-cutting concern is kept away from your business logic, and based on your requirement, wherever it is supposed to be get viewed or inserted at the right place, it will go and add that cross-cutting concern to get the similar behavior. Okay, the way it works is, if you take, when you write a business logic, okay, bank service, customer service and reporting, when there is a requirement for a security, okay, what you do is you go and write the security aspect where you have the security specific cross-cutting code here. Okay, and similarly, so don't worry about inserting now, but you know where to insert by having an expression which will be part of your security aspect, and you have a specific logic, that generic logic. Okay, and generic logic gets attached with an expression where that expression is going to find out which method you want to go and insert it. Okay, so similarly, like when you want to add the transactional behavior, you go and write the separate class or aspect to go and insert at the right place. Okay, and the same as a logging aspects. So now if you look at physically, I have two different classes, like different classes which is having a separate aspects logic. Okay, now what I do is, I know I've written the cross-cutting logic here, and I attach some expression where it has to go and insert at the right place. Okay, that insertion of this generic logic at the right place will be done at the runtime or build time or loading time, and give this whole this POJO and this aspects to a framework. At the runtime, it will go and insert all those code at the right place, with the right place being selected by the an expression which is there in the an aspect. At the runtime, if you go and look at the snapshot of the each class, it looks like the same behavior, but physically all the codes are separate like this. If you go and open the physical class, it doesn't have any cross-cutting concern inside, but at the runtime, all this cross-cutting like aspects gets viewed into actual class to insert that logic. Okay, so that way I can actually maintain this code with having a two different classes, aspect in one class, business class in another class. Okay, but at the runtime, I will have the similar behavior, similar effect by having this weaving technique. Okay, that's how the AOP works. AOP is a concept. AOP is a concept. It has been implemented by different frameworks. So one of the framework is Aspect J. Okay, the other one is Spring AOP. Aspect J is so originally like AOP. The whole technology has been invented that time. It was the first version in 1995, and the Aspect J is as old as Java. Okay, it was there from the beginning. Okay, and at the same time, it has a full-blown features, aspect-oriented language features. Okay, a lot of features, and at the same time, it is complex to use. Okay, so that's Aspect J. What Spring has done is, it has taken some subset of the Aspect J feature. Let's say like if it's taken some 20% of the feature from the Aspect J, and that is actually solving around 80 plus percentage of the problem in building enterprise applications issues. Okay, it just focus on those problems which is there in the enterprise applications. Okay, so Spring AOP is implemented using this Aspect J concept only. It has borrowed some of the things from the Aspect J and implemented, which is going to solve maximum problems in my enterprise building applications. Okay, so one key difference between Aspect J and AOP is a weaving technique. So in case of Aspect J, it uses this bytecode modification for weaving the aspect weaving. When I say bytecode modification, it actually goes and modifies the .class file during the loading. Okay. In case of Spring AOP, it is actually uses the dynamic proxies. That is a Spring proxies for aspect weaving. Okay. So in this session, we'll focus on how to solve a enterprise building applications using a Spring AOP. We'll focus on this. So before getting into an example or how to set up, we'll try to understand few concepts which is there in the AOP. Okay. The first one is there is a join point. So what is a join point? The join point is a point which is already exist in your program. Like all the existing methods are called as a join points. A point in the execution of the program, such as a method call or exception thrown. So those are the point where I can go and insert the code. So it is not that you are going to write anything. Join points are already exist in your application. Like all the methods in the class are the join points. Okay. And a point cut expression, it is an expression that selects one or more join points or subsets of the join points. You go and write an expression. That expression is going to select one or more join points. Okay. That's called as a point cut expression. Okay. So now advice. Advice is a piece of the code to be executed at the selected join point. This join point has been selected by point cut expression. Okay. There is a little piece of the code which will go and execute or insert at the selected join point. This join point has been selected by this point cut expression. Okay. That's a advice. So aspect is a module that encapsulates the point cut expression and advice. So all those things together like point cut expression and bind this to an advice method, together I'll call this as an aspect. Okay, that's an aspect. So weaving is a technique by which aspects are combined within the main code. So weaving is one more technique. Like in case of Spring, I use a Spring proxy object or dynamic proxy way of weaving. Okay. So this is about few concepts. Okay. Now we'll see how we'll take an example and see how we can actually make things work with an example. We'll start with a very simple thing. Okay. Let's say I have the requirement, very simple requirement. I log a message every time a property is about to change. Okay, this is my requirement. So how do you do this using a Spring? So let's say I have this interface which is a cache and this is an implementation. I have this method set cache size and other method. Now I have defined all these properties. Okay, I want to log a message before a property is about to change. Okay, let's say there's a Spring AOP is not available. If I want to log a message when the property is about to change, where will you go and add the log message? Where will you go and add the message, logging message?
In every setter method that we have.
Right. So I'll go
Yes,
and
in every setter method.
yeah. So I'll go and add the logging message on every setter method before changing this attribute, right? And if I have one or two classes, fine. But if I want to log a message across my application, I have to go and add that code changes across my application. Okay. So that's how I have to go and do it. Okay. Let's see how I can do it in case of using a Spring AOP if I use it. So now what I do is I'll go and define a logger. I'll go and write a separate class which is like property change tracker. Okay, I'll define the logger here. I'll go and write this method where say log dot info at the info level a property is about to change. This is a log message I want to log. Okay, and I'll put this log message in a method say track changes. Okay, I will write everything this. Okay, and I will put this in the class, and now I'll go and add this aspect annotation. It is missing, and for this method I want to go and insert at the all the setter method. Okay, now how do I go and insert this this generic logic at the all the setter method? So for that I'm going to write a point cut expression. The way my point cut expression looks like is I go and add this starting with set. Okay, I want to select all the method which takes a parameter. I go and execute, get all the methods which is there in the my all the packages in my application. Okay, so this method, the code has to be inserted before even executing this method, or before even that method is getting called, right? Because I want to say that property is about to change. Okay, so for that I go and indicate that I wanted to log this at the before. Okay, don't worry about this expression now. We'll talk about this expression a little more detail later. For now, let's understand this expression is going to select me all the method which starts with a set in my application. Okay, so now what I have done is I have created a class and I have created a method, and together I made this as an aspect class. Okay, and I have created a point cut expression, and I've added this where I need to add it, in the sense before calling the set method. Okay, so this is the one piece of the code where I written as an aspect completely. Okay, and also I marked this class as a component because I want to create this as a bean. Okay, so these are the few configuration I've added to my aspect class. So now I have done with an aspect class. I need to go and enable the AOP. By default, AOP will be disabled in the Spring, so you need to go and enable it. So the way I can enable in Java configurations, I go and use this annotation called enable aspect J auto proxy. Okay, so when I put this behind the scene, it will set bunch of beans, and some of the beans which are there is the bean post processor. Okay, in case of XML, I'll go and add this namespace, which is the AOP. I say aspect J auto proxy is my tag. So in case of XML, you do this. In case of Java configuration, you go and add this enable aspect J auto proxy. Okay, and since I have added this at component here, I will have to go and scan and treat it as a bean, turn it into the beans. So for that, I go and create a component scan. Okay, I go and create a component scan to go and get that as a turn into the bean. So this is one configuration I will go and do it in an XML or Java configuration. Okay. In case of XML, I'll do this component scan. In case of Java configuration, I do this component scan annotation, the base package. So normally this configuration, I will keep it in a separate XML file, aspect J config.xml file. Okay. And then I will go and include into a main XML file or main Java file. Okay, so when I'm writing the aspect into Java configuration, I'll write a main config Java configuration. Here I do an import of an aspect configuration, which I've written here. So this is my aspect config where I've enabled an aspect and do the component scan. So I include this in our main config. Okay, for a testing purpose, I'll go and create a beans for the simple cache. So cache A, cache B, cache C. Okay, all these will create as a bean. Okay, and I have an aspect. Okay, so now I have added. Now I will go and create an application context. So when I go and create an application context with the main config, which is already having an aspect configuration where I have enabled the aspect J Spring AOP with an aspects, I'll go and create it, and I get the context. Now with the context, I do a lookup with a cache A and say cache dot size set cache size to something. And whenever I'm calling this in the log message, you will get this property about to change when I'm testing this application. Okay, so these are the few configuration changes you need to make it enable the Spring AOP to work. Okay, now we'll see how actually this works behind the scene, how these aspects are applied. Let's say I have this cache interface, and a simple cache or class has been created using this, implemented using this interface. Okay, whenever you create a Spring bean in your configuration class, okay, in the part of lifecycle creation, okay, there is a bean post processor. So one of the bean post processor, when you enable this Spring AOP, a bunch of bean post processor will be set up. So one of the bean post processor will go and check, is there any aspect is been created. Okay, if there is any aspect, it will take that aspect bean and take an expression. Okay, it takes that expression and see whether that expression is matches with this simple cache bean object. Any of the method is starts with a set here. Okay, at least if one method is matches with that point cut expression, at least one method, if it is matches, then what Spring does is it will go and create a Spring proxy object in the bean post processing phase. It will go and create the Spring proxy object. So when it creates a Spring proxy object, this guy is going to implement using this cache interface, and it keeps a reference of the target method, which is simple cache object, and also it will keep a reference to the property change tracker, which is an aspect, which I've created as a bean. That's an aspect bean. Okay, this Spring proxy object will keep a reference of these two, and there is a method interceptor. Okay, so now whenever you are invoking this set cache size, okay, and before that, whenever you're trying to get lookup simple cache bean, what you get is you don't get that a reference to this object, rather you get a reference to Spring proxy object, which we know already. Okay, now let's say you got it and you get the reference, and when you go and invoke this set cache size to some value, okay, a request will come to a Spring proxy object. The method interceptor will actually have a reference to a property change tracker, and it will go and check that method and point cut expression and check whether this method is starting with set and is it going to match with your point cut expression. If it is going to match, okay, then what it does is it will go and invoke that property change tracker, that change track change method, okay, and invoke that method, and then comes back and invokes the simple cache method, which is set cache size method will get invoked. Once it gets invoked, comes back and goes to the calling method. Okay, that's how it works behind the scene. The Spring proxy object will have a reference to a simple cache, which is a target object, and also a reference to an aspect. Any question about this so far? How aspects are applied?
Yes, Manju. Yeah, okay.
Yeah.
Yeah, in the previous classes you have told that Spring does not hold the reference for prototype objects.
Right.
So how the Spring AOP proxy will keep the reference, and how it will know that to intercept this particular method for the object? Like how will it keep track of the object, since it is not holding any reference for prototype objects or beans, not objects, beans, prototype beans.
Correct. So as I said before, okay, the initialization phase is common for all kind of beans, whether it is singleton or prototype. Okay, in case of singleton, container will hold the reference. Okay, in case of prototype, object creation will go through still the same process. Okay, proxy object will get created part of the initialization phase, which is a bean post processor after initialization. Right? Okay, proxy object gets created by the life cycle of the bean and given to you. Okay, after you consumed everything, after you perform, you have to make sure that cleanup. Okay, even though the proxy object comes to you, you have to make sure it.
Okay. Now at the time of bean post processing, the Spring now automatically adds this method or aspect, as we say it, to the proxy object.
Correct.
Am I correct on that one?
Yes. So this aspect is already having a reference inside my container. So this object will not get garbage collected. Okay, only this object will get garbage collected because it's completely the whole proxy and simple cache is given to you. It is not referenced anywhere else other than inside the proxy. When you are cleaning up the proxy, this will also get cleaned.
Okay.
Okay, is that clear?
Yeah.
Okay.
So Manju, staying on the same question, right? So if I call destroy on the proxy object, right? Will it be cascaded to the target? I mean, sorry. Yeah, if I call destroy on the proxy object, will it get cascaded to the prototype bean?
Yep.
But the problem here is the proxy object itself might be a singleton, right?
It's a one object. Proxy object is not a singleton. If it is
Oh,
defined
it
as a
is.
prototype, it's an object for you.
Okay, so it's an object, meaning
It's a
is it a prototype or a singleton?
which case you are talking about? Are you talking about the singleton or are you talking about the prototype? Because you
Okay,
have
so
different.
what happens is, yeah, so the target, uh, so the proxy object can be a singleton, but the target class or the target bean can be a prototype, right?
No, because you are defining only a bean definition for simple cache, not for the proxy. Proxy gets created by Spring. It really doesn't matter whether what scope you have given. Irrespective of that, the proxy gets created if there is a special things need to be done, like this.
Okay, so is it like the proxy is one-on-one with the simple cache instance?
Yeah, for all the cache A, cache B, cache C, what you are defined in your configuration class, okay, there will be a
Okay.
separate proxy object created for each and every bean.
Okay, so which means if the bean is going to be a prototype bean, we'll have multiple instance of the proxy as well, right?
Each bean will have its own proxy.
Okay, got it. Okay, thank you.
Okay. Is it addressed your question?
Yes.
Okay. Any other question? Is it clear? If it is not clear, please ask me.
Just a clarification, Manju. So in the last session we were talking like if I don't implement the interface, it goes with the Java proxy. So
Hmm.
it holds good even in this case.
Right, right.
Okay.
Okay. All right. So this is how the aspects are applied behind the scene. Okay. Now onwards, we'll be talking and looking at how these aspects gets applied for the different scenarios. Okay. Now let's say the log message which we are logging, it's very simple and it really doesn't make much useful message. So now I wanted to really log a message a little more with more information. What is the method? What is the value it is going to change? And what is a bean ID? Things like that. So if I want to get all those information, so what Spring Proxy does is this aspect method is a little flexible. Okay, so when you add this join point to this method, so what Spring Proxy does is whenever you call the set cache size method, Spring Proxy object will collect all the information. What is the method name? What is the arguments? And what is the bean ID? And populates this join point object and gives that information to your advice. My advice is a track changes advice where I want to log it. So what I do is I take this join point, get the name of the method and what is the arguments it's been passed to that method, and I put it into a log message. Okay, I put everything into log message and also I'll see what is my bean ID. So get target will give you the bean ID. Then I say this is a method about to change to this value on this bean ID. Okay, so this kind of message will be little more useful. Like set cache size is about to change to this value on this bean. So it's written. Okay, so this kind of information is passed to a join point. This join point object is created by Spring Proxy object and populates all these required parameters to be added. Okay, this method is signature. We can go and change anything. Okay. So that's about the way I can set up. So now let's look at the point cut expressions. Okay, as I said that Spring AOP uses the aspect J point cut expressions. It did not reinvent the same wheel again. It took the existing aspect J point cut expression, reused it. Okay, whatever it is there in the aspect J definition expression language, which is available here, it's the same thing is being taken by Spring AOP to do it. Okay, so you can go and set the practical subset of aspect J point cut expression. So we'll take a look at how this point cut expression works. Some examples. So if you look at that, I have an execution designator, and inside this it will take the method pattern. Okay, the way the method pattern looks is I have a modifier and return type. This is the class type, method name, and method takes a list of arguments, and it's optionally it will throw a exception type. Okay, so this is my method pattern. I can go and define an execution with a method pattern, and if I wanted to make it something like little more composite or complex, I can go and add this simple expressions, execution designator expressions, using this composite, and or not I can use this to make a chain of a composite point cut expression to make it a little more complicated. Okay, that's about point cut expression. The way I can go and write an expression, if you look at, this is the designator, execution is a designator, and the first parameter is always a return type, and this is the package. Okay, then this is the class type, and then the method type, and after the method you have a parameters, and you can specify the expression also here. Okay, return type, if it is star means any object of any type. It can return any object of any type. Star means here. Okay, and rewards dot restaurant. After that there is a classes. There are classes. The class name ends with a service. Any class name which ends with the service will get picked up here, and all those service classes, and the method which is going to start with a find. Find star means find by customer ID, find by phone number, find by email ID or whatever. Okay, all those methods will be get picked up under the classes which ends with a service. Okay, those methods, which is a find by methods or find methods, which takes dot dot means it is a 0 or more parameter inside. 0, it could have no parameter, also a more parameter. When I indicate dot dot means it is a 0 or more parameters. Okay, let's take some example and see how the point cut expressions can be built. Okay, can you tell me what is this point cut expression does? What this point cut expression does?
This aspect will be executed on all method starting with send and taking a string parameter and returning nothing.
Okay, good. It takes in all the packages in your application, all the classes, any classes which has a method starting with a send, and take the string as a parameter and returns void. Okay, so what is this says?
Any method
all method with the name as send, and it doesn't matter what parameter take and what return.
Okay,
but it will take only single parameter, if I'm correct.
Yeah, so here the difference is the method name should exactly match with a send in any package, any class. Okay, and this send method will take only one parameter of any type. It is of any type, and also it returns an object of any type. It can return any object type. Method should match exactly the send, and it takes one parameter of any type and returns one object of any type. Okay.
Does it include void as well, or it does not include void?
It doesn't include, I think.
Okay.
So what does this says?
Any method, any send method in any class or package which has first parameter as int and any variable number of arguments after that,
Right. So
and
here,
returns anything.
correct. So method name should match exactly send, and this method starting parameter will be an integer. After that, you have a 0 or more parameter of any type. Return any type. Dot dot means 0 or more parameter. Okay. Okay. So what does this expression says?
This will apply to the class message service IMPL and package example, and this is to all method which return void.
All right. So in the example package, I have a class which is like message service implementation, which is IMPL, and in this class, all the methods, okay, which takes a 0 or more parameter and returns void. So those methods will be get picked up, which is matching with this. Okay, all the visible methods. So what is this says? Hello?
Hello.
What is this expression says?
Yeah, actually, any send method in example message service which takes one single argument and returns void. One.
Right. So here, example package, let's say if the message service, if it is an interface, okay, if it is an interface, any child of message service interface, any child implementations will get picked up, which has a send method, which takes a one argument of any type, returns a void. If it is an interface. If message service is an abstract class, all the children of message service implementation will be taken, which has a send method. So this is applied for in those cases as well. Okay, that is one thing. So what does this says? What does this says?
Hello?
Yeah, what does this says?
This will work on those methods starting with the name send and which get passed after the security and security rules.
Okay. So if you look at this, this expression is little different. It says like there is an annotation here. Okay. So what is that means is any method which starts with a send, okay, which takes 0 or more parameter, and only the method which is having with this pattern has this annotation, roles allowed annotation, then only those methods will be picked up. So roles allowed annotation been added to this send method. Only those methods will get picked up. Even if you have any send method, if this annotation is not there, those method will not be get picked up. Okay, so it is based on the annotation. Okay, where the roles annotation is added for that. Okay, so what does this says? What does this says? Okay, so this says here rewards is a package name and restaurant is also a package name. In between rewards and restaurant, there is one more package folder. Okay, so since it is a star, it is having one level of folder is available between and ends with this restaurant. Inside the restaurant package, you have a class in all the classes, and inside that classes, all the methods which take 0 or more parameters and returns any of object. Okay, so if you want to work with the packages, you can use a star and dot things like that. Okay, so what does this says? There's a dot here.
Different packages.
Yeah, so
in between the rewards and restaurant.
correct. In between the rewards, starting with the rewards and ends with the restaurant. In between, I have a 0 or more folders, multiple folders between these two. Inside that restaurant, you have a class, all the method which takes a 0 or more parameter and returns so any object.
Hey Manju.
Yep.
Hello. I have one question here.
Yep.
So under this pattern, if I have one final class defined matches with this pattern, so will it get intercepted by AOP?
If it is a final class, even if it is matching, it will not be able to create a proxy object, right?
Correct.
Yeah. So during the first part of the bean life cycle itself, it will not picked up. Okay, so that means the special logic will not be applied on those classes.
Correct.
Okay. So what is this says? Start star dot restaurant star dot star. There will be one package in the beginning and ends with a restaurant package, and all the classes inside the restaurant package are all the method in each class, and let's take 0 or more parameter. In between the first and then between you have a 0 or more pack folders also, so multiple subfolders. So that's how an expressions can be built. You can also play around with the packages, functions, and classes type, and also you can add the annotations. Okay, so that's about a point cut
One
expression.
question.
Sure.
Manju, for the classes, is it valid for the inner classes as well?
I think it will validate as long as if it gives that path in that way. I think it will apply that, but it has to be in the expression. I have not tested this for the inner class. I think you can make it work. I'm not 100% sure because I have not tested.
Okay.
Hmm?
Yeah.
So let's see different advices which are there in the system, which we have. Okay, one way.
Manju, this again, staying with the same question, right? So inner classes, right? Can inner classes be made as a bean or a component?
I think you can make it.
Okay, so if that is possible, then okay,
Yeah.
this
So,
should be possible.
yeah. So because we saw that in the test class where we can go and define an inner configuration class that will create as a bean inside that. It will get picked up.
Okay.
I think it is possible, but I have not tested that scenario. Because in inner class, when you go and add inner class, at the inner class level, you will go and add the component, right?
Right.
So only I'm not sure about the pattern, how to pick up that class, because the class you need to provide, right?
Yeah.
That pattern I'm not sure. But as a creating a bean object, yes, it will get picked up.
Okay, so in that case, I'm guessing it should not be like class dot method. In that case, inner class would not qualify. The class dot
Class again.
Class again,
Correct.
yeah. So,
Yeah. But I really don't know about how the pattern will support the inner class also. I'm not 100% sure. Okay. So the advice which we saw a previous example is a before advice. So here is the sequence diagram. If you look at, I have a proxy object. When the target method been invoked, it will come to first to a proxy. Proxy will have a advice, the aspect reference. It will go and call the proxy, that aspect method comes back and invokes the target method. This is actually set method, and this is a logging aspect advice method. Okay, once this comes back and goes back to the calling method. This is a one advice type, which is a before. Okay, the way it has been annotated is using this before annotation, which we saw. Okay, only thing is you need to make sure is this specific the logic which you are going to put, generic logic, will not throw any exception. If this guy throws an exception, it will not even invoke the target method. Okay, so that is one thing you need to take care of it. Okay, okay. The another type of advice is the return after. Okay, after returning, which is like if you look at this any method call. Okay, while returning, it can return an object. Okay, or it can throw an exception. Or either case, whether it's an exception or a success case, I want to do the something out of it. Okay, so if you return, I have three different cases. One is return successful and return exception, and either case I wanted to do it. Because there are three cases been covered in this here advice. After returning, like now you invoke the proxy. First thing is a target method will be called. After the target method successfully returns an object, then I'll go and call this after return advice, after returning advice. Okay, that piece of the method will be get called and comes back, goes back to the proxy object. Okay, so if you look at the example, the way it works is I will go and add this annotation, which is an after returning. Okay, after returning will be taken here, and I have a method. This method will get invoked after the service method gets invoked. Okay, now let's say the object, that function is going to return you an object. I want to catch hold of that object and extract some information and put into log or send an email or send an SMS, things like that in this advice. So what I can do is I can get that object using returning. Okay, in the advice I can go and say returning equal to reward. The reward and this reward name should match, not this part. Reward and this reward should match. This can be any type. Okay. In case of the method which is going to return, if I put this reward, the functions which is going to return the reward object, those methods will get picked up by this expression. There's a tricky part here. If you look at, I have the star, but what I'm saying is I will get only the method which are returning the reward. So what it does internally is, internally it goes and updates the point cut expression with a fully qualified package name and class name here. So that this point cut expression will always execute the method which is going to return the reward object. Okay. So now you take the reward object and get print message, whatever you want to do, you do it. That's about after returning. Okay. So there is another advice after throwing. Let's say target method throws an exception, then only I wanted to invoke this advice, which is after throwing advice. So proxy will invoke the target method throws an exception, comes back, and I go and invoke the after throwing advice method, comes back and goes. Okay. The way I can implement is there is an advice annotation called after throwing. Okay. In the after throwing, I'll go and put an expression, and also I'll say throwing, and that is the exception I'm going to catch as an E, and E should match. I can have any kind of exception. So internally, it will again go and modify the point cut expression to match that method signature should throw a data access exception kind of things. Okay, only those methods will get selected, and this advice get invoked for that. Okay, in this case, like I want to catch that exception, and in the failure case, I want to send an email message saying that this specific operation has an exception. I can go and throw this. This is about an after throwing. Okay, there is, irrespective of whether it is throws an exception or success case, I still wanted to do the case. So that is another advice. So in the after throwing, okay, so if you look at here, the target method throws an exception. Okay, here the target method throws an exception. When you perform this after throwing, you cannot nullify this exception to throw back here. Okay, so always the exception will be propagated to the calling method. Who are calling that function, you will get an exception. Here you cannot go and nullify this exception, catch it and nullify, you cannot do. Another thing is, what you can do is you take this exception and you can rethrow the different exception. That is possible. Instead of this exception, whatever the exception you are throwing inside it after throwing advice method, that exception gets thrown. So you can actually throw the application specific exception or something generic exception, you can throw it here. That is possible. The way you can do is, inside this, you can actually go and rethrow this, throw a new any specific or generic exception to the calling method. At any cost, you cannot stop the original exception. Either the original exception will be sent, or the exception which is thrown from this advice will be sent. Okay, that's an option. So now there is another advice which is an after advice. After advice is like proxy will come here and invoke the target method. Doesn't matter whether it is a successfully returned or exception, I still wanted to go and invoke the advice after this. Okay, this advice will get invoked, comes back, and goes back to the calling method. So the way I can implement is, I have an after advice, an expression, and here I don't know whether it is a success case or failure case. So I cannot get hold to those objects, returning object or exception. Okay, I just wanted to make sure that it is actually completed after successfully invocation. I don't know whether it is completely passed or failed, thrown an exception or successfully done. Okay, you can just say this is being called and completed. You don't know whether it is successfully completed or it has a failure. So regardless of exception or success, this method will be get called. Advice will be called. Okay, so these are the after advices. Okay, before, after returning, after throwing, and after. So these are the 4 different advices. Okay, there is one more advice which is called as an around advice. Okay, what it does is it is very special advice. If you look at the request will come to a proxy. Now proxy will actually invoke the around advice. Okay, now you will get a control to your advice method. Okay, now you have an option to go and invoke the target method. Now you have an ability to go and call this target method based on your need. In the previous cases, the proxy itself directly calls the target method. Only after that your advice get invokes. In this case, it is very special case, and control is given to you, and also it will let you know how to invoke the target method. So based on your logic, you complete some logic before invoking and proceed with calling the target method, come back and do something. Okay, now you have an option around the target method, whatever you want to do. So here are the things like, if you wanted to do, if I use the around advice, okay, before invoking a method, I want to open a transaction here. I will open the transaction, then I will call this proceed method, target method, does everything, comes back, and I do a commit. And if this guy throws an exception, I'll catch an exception and roll back. Okay, so that kind of piece of the code I can put it in my advice itself. Okay, if I want to do a security check, okay, I do a security check here and invoke the target method if it is success, otherwise don't invoke. Okay, or if I wanted to put a instrumentation log, entering and exiting this method, I don't need to go and put it here. I'll put this on entering and call this method and exiting, and take a time note of the time here, and take a note of the time here. This time versus minus this, if you do it, it will give you the how much time it has taken. Okay, so like you can use this advice, around advice, for many purposes. Okay, logging in, transaction, security. If you want to do something retry, let's say you invoke the target method, it is failed, and now you wanted to retry 3 times. What you can do is catch an exception in the exception block, go and call this target method again, come back. Okay, so all these sort of things you can actually do it in around advice, and it is very powerful. Okay, the way I can do it is I have an around advice and put a point cut expression fully. And in the around advice, the special thing here is you get the preceding join point object. Okay, the preceding join point object, using this preceding join point object, I can actually call the target method. Okay, the way I'm calling is, say the point, I say point dot proceed. Here is what I'm calling the actual target method, and I'm calling in the special conditions. Let's say this specific logic, what it does is it is trying to cache it. If it is already there in the cache, if it is there in the cache, it will come back and return that object. If it is not there in the cache, then it will go and invoke the target method and comes back with a value, and this value it will put it into a cache and return that. Next time when it is hitting the same query with the same value, then it will get it from the cache, and that cache object will be returned here. It doesn't go and invoke the target method. So this way your caching will be effective to increase the performance. So same as open the transaction.
Manju, question.
Sure.
Yeah, so if the target method has a return type called employee, just imagine. So when we come into this method, right, we are actually having an upcasting to object, right?
Correct.
So when this goes out of this method to the back to the proxy takes care of downcasting it to employee, is it?
Yeah.
Okay.
Or else you can actually, if you have a specific need, you can go and return that object itself. See, most of the time this kind of things will be a very generic. Okay. So
Yeah.
generic way, you can go and do a generic objects. If you have a specific need of things, you can go and return the specific object where the caller method will take that object directly.
Yeah, sure.
Hmm?
Thank you.
So you can do many things. Okay. So this is where you will get a power to do adding a additional codes. Okay. This is very powerful. So far what we saw adding is all the annotations using annotations. This is possible in two ways. One is you can use an annotation, or alternative to this is XML. Okay. If you do, for some reason, if you don't have a features annotation feature in your JDK, if you're stuck for below JDK 5, then still AOP Spring AOP supports to define all those advices using an XML itself. Okay. Preferred way of doing it is always an annotation. So if you're already having it, use the annotation based. And if you don't have the annotation feature in the JDK, then you fall back to XML. So XML, you need to go and use the AOP namespace. In the class, you just go and define the plain thing. This is my class and this is my method. Okay. There's no annotations. And in XML, you go and define AOP namespace and AOP config, and you go and define a bean for that Java class, and you go and refer this to an aspect. Make this as an aspect first. Okay. And inside the aspect, you go and define what is the advice you want to use. So I want to use an advice which is like AOP before, and you have like other tags, AOP colon after throwing, after returning, and around, and before. So use whatever advice you want to define for this specific method, put a point cut expression, and point to which method you want to call upon matching it. Okay. With this configuration, you will be able to enable the Spring AOP using an XML. Okay. So that's about it. It works most of the cases, but there are some limitations with the Spring AOP. As I said before, any feature in the Spring, it is only applied to only a Spring beans. Okay, aspects are applied for only Spring beans. If it is not part of your container, this aspect will not be applied. Okay, that is first thing. And second thing is it can apply only for a public method, which is a public visible method. Okay, the preferred way of doing is always use it for interfaces. Okay. Interface way of doing it. Even if you don't have an interface, Spring will be able to support creating a proxy using a CZ library. Okay. However, while weaving, we have some limitations. Let's say your interface or class has two methods. Okay. One is like method A and method B. Okay. If in case method A calls method B inside, okay, and the advice will be applied to method A but not to B, even though B is eligible to apply, because if you call the method B directly from the outside, the advice will be applied. Since it is calling from the A, B is called from the A, the advice will be applied for only A, not to the B. Okay, because the control is already given to A, Spring doesn't have any hold on it. This is the target methods. Okay. So advice will never be executed on the B method. That's one limitation. With this limitation, still I'll be able to solve many problems in building an enterprise application. Okay. So that's about AOP. Any questions? Open to the questions.
So the last point you mentioned, I'm actually assuming that it would hold good for even the Spring's out-of-box aspects like transaction and security. So, for example, let us take transaction. So if I call a method, only if it is a public method, I mean, what I'm saying is I call a method, a public method. If the public method is basically having, making a call to the private method, the private method will not be in the transaction.
Right.
Right? Okay.
Yeah, that will not be applied.
Okay.
Okay. I mean, when I say that advice will not be applied, I don't know what you are putting in the advice. It could be logging, or it could be a transactional, or it could be security. I don't know what you have put, but advice will not be executed for that.
No, what I'm saying is the transactional advice which Spring would have implemented.
But if it is, see, if you have a method A, okay, and you are opening the transaction before this, and if you are calling B, and B is also participates in the advice, this transaction, because you are opening the transaction, you go and call this method B and come back and return back to the proxy. So whatever the scope of a whole thing will be in the transaction.
Okay.
You got what I'm saying, right? Only thing is,
Yeah, got it.
only thing is the advice
No,
will
I'm
not be
just
applied to this, but it will participate in the transaction.
So I'm just thinking about the other ways in which we control the transaction, right? The supported, not supported, you know. So I'm just thinking how. Okay, anyway, that's for a different schedule.
Sure. Any other questions?